All right, so we are now going to look at how to use elementary row operations in order to solve a system of equations. I am going to walk you through how to solve this with algebraic operations first, and then I'll go back through with the equivalent row operations so that this makes sense here. So the way in which we would solve this system with algebraic methods is we could multiply this first equation by, let's say, -5. So we could say -5x1 plus 10x2 minus 5x3 equals 0. And I really only want to carry through here that bottom line. I'm going to use that method of elimination. That tells me that 10x2 minus 10x3 must be equal to, oops, that should be a 10. Or we could say x2 minus x3 equals 1 if I multiplied this by 1/10. All right, well now let's use this line here and let's multiply this line here, let's say by a -2. Let me write this down. So 2x2 minus 8x3 equals 8, and -2x2 plus 2x3 equals -2. Here we're going to get those to cancel. So I get -6x3 equals 6. And so I get that x3 must be -1. I can then go back into any of those other equations and back solve this. Let's just go with this one right here because it's right here in front of us. So I know that x2 minus -1 equals 1. x2 plus 1 equals 1. Well, then that means that x2 must be 0. And then let's go all the way up and let's see. I need to solve this for x1. I can use either one of these. I know that x3 is -1. Let's use that bottom one. So 5x1 minus 5x3 equals 10 is the one that I'm using. I'm going to plug in that. Five x1 plus 5 equals 10. Subtract 5, and I get that x1 is 1. So my solution, I'm going to still write this as an ordered pair, is 1, 0, -1. All right, now let's do this exact same equation, system of equation, but we're going to use a matrix instead and use elementary row operations. All right, coming back up here to the top, I'm going to write this as 1, -2, 1, and I'm going to augment this with 0, 0, 2, -8, and 8, and then 5, 0, -5, and 10. Now let's go up to our things here. Replace one row by the sum of itself and the multiple of another row. Interchange two rows. Multiply all entries in a row by a non-zero constant. So these are the three things that we are allowed to do on here. Now, the first thing that I actually want to do is I want to do this scaling step. I'm noticing that I can multiply row 2 by 1/2 and decrease all of those constants by that factor of 1/2 to make this a little bit more simple. I'm also noticing that I can multiply row 3 by 1/5 and get something very similar where I'm going to be able to simplify that row. So let's go ahead and do both of those row operation steps. Nothing happened here to row 1. I'm going to essentially divide everything in row 2 by 2. And then I'm going to divide everything in row 3 by 1/5. And so that's called that scaling, okay, that scaling operation. Right now, I don't want to switch any of my rows, but I do want to do that like adding, subtracting. Let me go up and do the exact words here. Replace one row by the sum of itself and the multiple of another row. So what I like to write here is I'm going to replace row 3 by taking row 1 and subtracting row 3. And I'm going to put that back into row 3. It's very similar to this step here, in which we're kind of doing an elimination step, if you will, and you'll see that my x1 here ends up going away. See if I can go just a little bit. There we go. Okay. So everything except for row 3 is going to stay the same. And I'm going to take the digit in row 1 and I'm going to subtract row 3. 1 minus 1, 0 goes here. -2 minus 0, -2 goes here. 1 minus -1, 2 goes here. 0 minus 2, -2 goes here. So all of these entries in row 1, you're going to subtract the entries in row 3 and then put them back into row 3. Now again, I'm going to multiply by a 1/2. In this one, it doesn't look like I'm going to end up using that second row operation where I could switch rows, but we'll have plenty of examples of where we'll be able to do that. All right, now if I take row 2 and I add row 3 and put that back into row 3, I'm going to end up zeroing out this part right here. So let's look at that. All right, 0 plus 0, that gives me 0. 0 plus -1 gives me 0. -4 plus 1 gives me -3. And 4 plus -1 gives me 3. Well, remember, if we go back to this being a system of our equations, that means that this, if I write this the other way, that this must be true. Well, then x3 must be -1. Another way we could do this is we could have multiplied this by 1/3 and gotten that, or by -1/3 actually is what I'd want to do here, and we'll get 1 equals -1, and then you'll have your solution. More on that kind of in our next section of videos, but know that that's a possibility as well. Okay, and then you could then back solve this just like we did before. Once you have this one solution, you could go back and you could back solve this to get your full solution here. And that is just an example of how we're going to use those elementary row operations. to solve systems using matrices.